Hello, this is Dr. Uli Scholten from Skyreader speaking. Today, we will talk about AI in ATM, but we will look at it from a specific angle. We look at it from an architecture point of view. What architecture is required, and also, of course, through the eyes of the ATSEP. What will the changes that AI brings and the impact it has on architecture mean for the ATSEP? We'll also talk about regulations, we'll talk about cybersecurity, and we talk about, of course, the changing profile of the ATSEP. But our starting point and our root point here is the architecture. Given this presentation a couple of times, the first one was given with our friends at Entry Point North. And then we traveled the world and did several webinars also remotely. I was in one conference, there was an ATM system provider who was asked, who was asked by ATSEP, how shall we behave given the emergence of AI? Do we need to be prepared? And the answer was, just trust in us. We always provided secure systems, secure products. And when we think AI is ready, we'll provide you AI. Dear friends, this is absolutely wrong. I would even say dangerous. You're investing now in architecture. AI is not a product. AI is a new approach. It's a new way of thinking, which requires a completely different architecture. When you invest into your ATM architecture today, this will last in parts for 10 years, perhaps even longer. So whatever you build now will be concerned by AI. Not only that, you will be concerned by quantum computing-based threats. So you have to be AI agile, meaning be able to react on applications from AI. And quantum agile means your system has to be able to rapidly grow in terms of security to adapt on new emerging threats from quantum. Our focus today is on AI, mainly on the architecture and the impacts. I also will talk about regulations, emerging regulations, and the changing role of the ATSEP. Be aware, I'm not a lawyer, so I can only hint what comes in terms of regulations and highlight what we need to consider. But always when it's about law and regulations, please talk to the right people about it. So let's walk through the presentation now. The line of thinking in this presentation, I show you how AI is beneficial. I show you that it requires shared data and that it gets it through the cloud. It builds on cybersecurity, of course, backed by the regulations. Interoperability makes it more complex, and it has a big impact on the ATSEP job profile. That's what we're going to look at, and you can have access to the slides afterwards. Just contact me for more details. So, what is AI and how does it blend into ATC? I try to classify AI also in perspective of what we're doing here. And I'll talk about 3 versions of AI and their role in ATSEP, in ATC. First one is discriminative AI, which are the traditional AI models for prediction and classification. The second one, the ChatGPT thing, generative AI. It's about content creation. It's about data generation. And then we've got the big thing, which is about to come, large action models, or as we call it, reinforcement learning. The task focus is decision-making optimization. So decision-making, of course, is in direct conflict to the 2017 373 regulation, which prescribes human oversight. We talk about this. There's other less relevant groups, at least for our perspective here, like self-supervised learning, unsupervised learning, and so on. Let's work with my groups so they guide us through this presentation. What is discriminative AI. As I said, it has the focus on prediction, classification, and optimization. Examples are, for instance, flight delay predictions or traffic flow classification, classifying air traffic patterns for runway optimization, for instance, based on historical data. Route optimization using neural networks to predict the most efficient flight route. This reduces fuel consumption and congestion. Examples for the use in our ATSEP world: equipment failure prediction. We predict potential failures in ground communication system or radar equipment using regression models. This enables us to apply proactive maintenance. Ground-to-air communication monitoring, it helps us to classify and monitor communication based on aircraft and ground control to detect anomalies and signal degradation in real time. So that's already quite a good help. Then we've got the generative AI, as I said, the thing that we have in ChatGPT. This is helping us with content and simulation. We can generate automated reports with large language models. We can simulate emergency scenarios, and we can assist ground-to-air communication or ground-to-ground communication with interpreting pilot communications and just suggesting appropriate responses, improving interoperability and really reducing human errors. Technically, you could even imagine that a chatbot is starting to communicate with the pilots. Examples for ATSEP are interoperability scenario simulation, when a generative AI simulates cross-system interactions like radar, ground communication, surveillance systems. It allows to test for interoperability issues. And we can generate automated troubleshooting guides for equipment issues, enabling ATSEPs to resolve problems faster with fewer communication breakdowns. The whole service jobs, hotlines are more and more getting into that kind of AI support with a talking chatbot behind. From my point of view, the big revolution to come are the large action models. It's in the name, it's action. So it's more than just suggesting something, it does something. Decision-making, dynamic optimization, and automation. Examples are dynamic conflict resolution. Their reinforcement learning helps resolve potential airspace conflicts by dynamically rerouting aircraft. So it's difficult for the ATCO and for the ATSEP to follow that. There might be hundreds of factors that blend into a decision by the system. So what role and what depth has human oversight here as prescribed by 2017 373? Autonomous traffic flow management. Again, traffic flow is optimized, and of course we can reduce the controller workload and of course save fuel and time. Automation in ground-to-ground communication. There we could imagine multi-agent reinforcement learning, agents in the aircraft and on the ground, which can automate communication between various centers, ATC centers, and the aircrafts for seamless handovers, improving interoperability across borders. Technically, it could work without persons. Examples for ATSEP are automation in maintenance and repair. Their reinforcement learning models can autonomously manage preventive maintenance for communication and radar systems and minimize downtime. Ground equipment optimization. There, the large action models could optimize the performance and development of ground-based navigation aids and surveillance systems in real time. Ground-to-ground communication system management. AI can dynamically allocate bandwidth and manage system loads across ground-to-ground and, of course, ground-to-air communication channels, enhancing system interoperability and reliability. So there is quite a lot to gain, but that's dangerous because how do we handle the human oversight? I try to summarize here. So in ATCO, We benefit from automation, interoperability, optimization across SIR, NAVCOM, and DPR systems. In ATSEP, we enhance the monitoring, the preventive maintenance, operational optimization, and of course, in emergencies, we can much faster drill down the symptoms to the root problem. So, explainable AI is a solution to a problem that I just stated a couple of times. Human oversight means we need to understand what's going on. So there is a new research field which is called XAI or explainable AI, which tries to bring transparency, interpretability, trust and safety, and accountability. So we try to allow us to understand how the system decisions are generated in order to judge whether what the system is doing, if we are in generative AI approaches, and in emergency or important cases, to correct the decisions. So transparency, it enables AI systems to clearly explain their decision-making process. Interpretability, it provides understandable reasoning for actions like air traffic flow adjustments or conflict resolutions, so the ATCO can react. Trust and safety helps build trust in AI by offering explanations for critical decisions. Well, that's clear. Accountability ensures AI-driven systems to meet regulatory and safety standards by allowing operators to trace and understand decision pathways. So it all comes back to one thing, to one root. We need to understand in order to release what is happening. Human oversight. What is AI's impact on the system and data architecture? Thanks to Uwe Schindler from Deutsche Flugsicherung, I got a couple of infographics which I'm using here and of course building on them. You see here a classical architecture of area control centers, which means that in the classical world, we've got decentralized, replicated on-premise data centers per ACC. They've got fully redundant processes. They might have completely different architectures managed by authorized ATSEPs. And we've got proprietary infrastructure with vendor-locked SMC data. So when you come to an ATSEP center, you always see that per provider, you've got different screens. Normally, the various providers don't allow for an integration of all their data to a central database. So in a cloud architecture, we bring data and applications together. In this new cloud world, we've got geo-redundant clouds with virtualized services, providing every ACC managed by authorized ATSEP. And we've got virtualized applications provided as a service with vendor-locked SMC data. So that's the current situation. So in this next step that I'm showing you here, we've got the data centralized and the applications are virtualized. You see that all the ACC centers are accessing the same cloud. We can have 2 or 3. Cloud 2 and Cloud 3 is just for redundance, or we are having them in several regions, so that let's say ACC 1 and 2 access data center 1, ACC 3 and 7 ADC access data center 2, and they are later replicated. Important is that all data centers have all information in a redundant way. This makes it more resilient. And we can, of course, load balance as well. So as I said here, we still have the virtualized services with vendor-locked SMC data. Here we show you another illustration, which is pretty much similar to the one before. You see our service-based architecture. The applications on top are operated as a service. with standardized data models, which are stored here. And we've got here on top AI-based ATC services like flight delay prediction, predicting most efficient routes, automated reporting, dynamic conflict resolution. And here below, you've got the classical services as you know them, like the flight data processing system, the radar data processing system, and so on. We've got several roles here, for the hardware. We can have external personnel, not necessarily ATSEP, who can manage that. Then we have authorized ATSEP following 2017 373 to manage the data centers. In some countries, the NSPs have even a higher level of licensing, the so-called license ATSEP, and this person will then take care of the higher level here, because there you need more understanding, or the best understanding of what's happening here. Be aware that here it's still difficult. I mean, we've got centralized data, so we can monitor the various services, but we don't have the control of SMC, so we cannot in a central way control, parameterize or optimize these applications. This is why we go to an even higher step of a service-based cloud architecture, allowing for system monitoring and control of the services, meaning configuration, parameterization, and optimization, perhaps self-healing. So we've got a configurable open system architecture with applications operated as a service. Important is always that all the services work with the same data model, so that we don't need APIs, application protocol interfaces, or a middleware that adapts the solutions for all the services here. So if they all have the same data model, we can access to it. And if we can parameterize in a standardized way, perhaps we need a standard or a regulation for that. These services, AI or the ATSEP, cannot only watch, but can improve the applications. And of course, improving the applications and rerouting or changing features means that we need to have impact on these applications from external services, like, for instance, here, predicting, and then the next step would, of course, optimizing, rerouting to the most efficient routes. If we reroute, we have to be able to access these services. This means we need to go away from proprietary architectures of the ATC system providers. We need to have at least per services standardized APIs where the central services, AI-based services, can monitor and can then even control and parameterize, perhaps even optimize these services. This is today not possible. So let's talk about compliance. The EU Regulation 2017/373 defines common requirements for the provision of ATM ANS services and responsibilities of service providers. One of the roles is the safety and risk management, safety assessment, risk analysis. Providers must comply with data and communication and system standards. The important points that I keep on stating here, because it has such a big impact related or role related to AI. Human controllers retain final decision-making authorities. Is that still the case in some years? Will that still be the case in some years? We'll see whether this will evolve. Of course, the controller will take the final decision-making, but does it mean it lets the AI change, reroute, and just intervenes when something is not good? Or does it mean it always has to press button, yes, go for it? We don't know yet. This is something that will evolve gradually. But systems must be designed with human oversight. Certification and enforcement, this specifies the role of competent authorities in certification, oversight, and enforcement of ATM ANS providers. So this is what the regulation tells us, and you see how it is related also to what comes in AI. So AI in traffic management under EU regulation, AI must pass rigorous safety assessments to meet the ATM ANS standards that we described before. It must allow for human oversight, giving the final authority to the humans. Risk management, risk analysis must be conducted to evaluate the potential impact of AI systems, especially in ground-to-air communications, where manual intervention might be required. In interoperability and compliance, AI systems must comply with existing ATM ANS standards for data communication and navigation, ensuring seamless integration with automated ground-to-air communication and human control. Let's talk about the limitations. Full automation is currently restricted. According to this, AI-based systems must operate under human oversight, ensuring the critical decision-making and that it remains with humans, especially in non-standard situations like emergency or system anomalies. Let's look at the emerging AI regulation. Please consider this is work in progress. Also, please consider I am not a lawyer. I'm looking at it from an architecture point of view, but I show you what's going to happen here. There's the EU AI Act, which is following a risk-based approach. You see you've got several levels here. You've got the green one, minimal or no risk, which of course there are no restrictions. Then we've got the transparency risk, and there it is permitted, but subject to information and transparency obligations. Then we've got a high risk, for instance, recruitment, medical devices, permitted, but subject to compliance with our AI requirements and ex-ante conformity assessments. Of course, most of the ATM systems will fall under that. And there's, of course, the unacceptable risk like social scoring, untargeted scrapping, and so on. So the EASA rulemaking is in strong exchange with that. We've got here the EU Act that I shortly presented the slide before. And this, of course, impacts the EASA basic regulation with the domain-specific regulations. And then we've got acceptable means of compliance, and then we've got industry standards joining in. So there's a whole layer of regulations and standards that interact with each other. And I will have a look at what EASA is showing us here in terms of basic regulations. So EASA is basing the regulations on a trustworthiness concept. We've got the level A, which is cognitive teaming and concerning human assistance. It concerns learning insurance, explainability, what we talked about before, and the continuous safety and security risk assessment. So this year, these services are a level 1. So it's just a cognitive teaming. You see there is no interaction yet. Level 2 is a human AI teaming. Meaning it goes further. There's really collaboration between a human and an AI system, but with the human making the decisions. It's getting more complex in level 3, where we talk about advanced automation. And there, of course, we've got it goes up to unsupervised automation, safety, risk mitigation. and of course of human AI supervision. So here we talk about the automation. And here EASA will define how human oversight will look and what levels of automation we would accept. But as I said, talk to your lawyer. Here's a release plan. Often these release plans take longer, but at least this is what is being planned. The AI Act application in 24 should have happened. And then the entry into application for high risk in 2026. This is the plan. And we're still developing harmonized standards, which should help us to regulate the emergence of AI in our ATCO and ATSEP world. Here there's more details about this. I will share the presentation with you so that you can really dive deep. So let's look at cloud AI, automation, and cybersecurity, because that is, what we're doing is we're interconnecting, we are opening our system, we're creating a centralized database. We should benefit from the phase that we can pool our control, but we should also be aware that we are opening more flanks for malicious intrusion. So let's see what the new EU 2023-203 and the ISO 27000 show us. So we talked about a couple of times about the EASA 2017-373. This is always our basis for our work. It obliges us to establish a security management system. And this security management system shall define procedures for risk assessment and mitigation, security model and improvement. It should detect security breaches, alert, should control the effects of security breaches, and identify recovery actions. The level higher is the regulation for management of information risks in aviation. So this is really where we dive deep. And there is a whole series of requirements. I think for us, the most important ones are the 205 information security risk assessment, information security risk treatment, the 2010. And I always like the information gained in the 2020 information security incidents, detection, response, and recovery. Just trying to give you an overview of cybersecurity in this world of centralized data and of cloud-based data centers. We require, as a cybersecurity toolbox or solutions, we require hardware security models. These are models where cybersecurity keys are stored and generated. We need key management systems for these keys. We need policy enforcement that define who has access to what, which data can be shared. And of course, we need the audit logging because these systems need to be audited. And then we have the public key infrastructure management solutions. And all these are then beaming into the various applications. I group them, people can group them differently, into identity management. And the identity means identity of humans, natural or legal persons. Then the protection of machine identities. If we get data from a radar tower or from a communication tower, we need to be sure that it's not fake. So also the radar needs an identity, or an application needs an identity, or a software needs an identity. You might even sign code coming from your radar to be sure that the Asterix protocol has not been compromised. And then we can digitally sign documents and messages as well. So the code, that's the software. The messages, that's the Asterix protocol that is coming from the radar tower to us. If it has been compromised, it shows an error if the message has been signed. Then we've got the access management. Can the radar tower send aspects messages into our SDDS system, into our message queue, which handles the data? Can it be distributed to the various controls, ACCs? That's about authentication and authorization. Also, who can read the data? We use the identity plus other factors to connect and correctly identify the right of people or things, and then give them the authorization to access. Important is that we protect the data. Encryption of data in communication and in transit is easy. Communication, that means it moves from one place to the other. Encryption of data at rest is easy. It's stored in a database and we protect it. What is difficult is the protection of data in use, because when it is in an application, it is unencrypted. That's often the point where the open flanks are generated or found. When we use cloud services like Azure or by Microsoft or the Google Cloud or Amazon AWS, we should make sure that we keep control of our keys, the encryption keys, because then we are really taking our responsibility. That's why I talk here about bring your own key as one of the important pillars of cybersecurity. I'm repeating that image again, which is increasingly deviating from what Uwe Schindler initially provided. We've got these applications, we've got compute, storage, and network, as we had it before, and we have to encrypt the storage, the network, the applications with signed code. Then we have to encrypt the communication between the various layers. And as you see, I was putting this world of the hardware security module, the key management systems, the policy, I was putting that outside this cloud. This might be on Microsoft Azure or on a proprietary cloud, but this ideally is somewhere else so that we can really protect it independently. And of course, if this is in Microsoft Azure, we should not want Microsoft to have the keys for the management of our data. We should have control of this. And let's now look how we can control data across many ANSPs. So this here is one ANSP with several ACCs and let's say 2 data centers. Now we start communicating. And the best implemented architecture that we can use is what Eurocontrol suggests as the SWIM compliant cloud architectures. We've got seamless interoperable data exchange between data integrators, airline operation centers, air traffic control, airport operators, pilots. And then we've got the various databases, which can be connected to one virtual database where our AI systems and our applications have access. So I took this from the Caesar fact sheet on SWIM. So SWIM enables centralized data for AI-driven ATCO and ATSEP operations. We've got the ATM information reference model, which with a standardized structure for ATM data, for aerodromes, ATS routing, airspace. So there is a data model. Let's use it. Let's not use proprietary stuff, which will prevent us from optimizing, from having AIs optimizing route, but also in emergency finding a root cause. Information service reference model. This is a logical breakdown of services, data exchange, and quality of service. This supports AI-driven optimization and automation in ATCO. Be aware, everything here about AI is coming from me. This is not Eurocontrol information, just to avoid misunderstandings. Information management functions and governance. Policies. You saw I had this cybersecurity cloud, where I talked about the policies for data access, security, and ownership. This ensures data integrity for AI-based system monitoring, maintenance, and operational optimization. So also this is there as a suggestion. We've got the SWIM architecture with which is an interoperable technical platform, ground to ground, ground to air, for centralized data. It provides the foundation for real-time AI processing and automation. And then we've got the SWIM-enabled applications. They deliver quality data for AI-driven hardcore automation. For instance, traffic flow, communication, and ATSEP tasks. Examples are system monitoring and preventive maintenance. So important is, if we go far with system monitoring and control, or AI-based system monitoring and control, that the applications that we get from the ATM system providers allow us to parameterize them, to change them, to control them. Now, this image comes over and over again, I show here SWIM versus GDPR between ANSPs and with application providers. General data protection regulation in Europe, and then SWIM, of course, is we have open communication between ANSPs. ANSP1, ANSP2. I took the same image from before. I think it's hardly readable now, but it doesn't matter. Important is that we have encrypted, policy-managed communication between the data of the one ANSP and the other. Important to know is that there are factors to understand. Data residency. In the EU, data needs to be hosted within the EEA by cloud providers like AWS, Azure, etc., or our proprietary data center with European data centers. So we must not let the data be hosted outside the EU. That would be a breach of regulations. Therefore, data residency. Data, so that's where it's hosted, but the data itself must be regional. That's what the term regionality says, meaning we can enforce as ANSPs data residency through regional keys, meaning when this data by mistake or by breach gets outside Europe, it cannot be opened, it cannot be read. Data sovereignty. In such an approach, especially when we bring our own keys or we manage our own keys, ANSPs maintain full control over data by implementing encryption, access control, security protocols, and we keep third-party access at bay. You remember there was that Facebook European court case when the Austrian lawyer Schrems brought the safe harbor regulation with the USA to fall. There is a so-called Schrems II ruling now, which by the CJEU, which emphasizes the need for data to remain in regions with sufficient protection, impacting transfers to non-compliant regions like the USA. I mean, this interdependence becomes a rule when, for instance, we've got flights from Paris to New York or from Frankfurt to Chicago. Then we have to make sure that only data which is in compliance with European regulation goes outside. And of course, in our AI-based architecture, AI-supported architecture, we have to make sure that a system which is acting under human supervision but relatively automated does not make us bring us into a data breach. So with all that, you see that the ATSEP role is changing. It's always the question, hey, isn't it the IT guys who do that? And what is the ATSEP role? Let's look at our new super ATSEP and what the role will be. And it's the future, and you cannot really know for sure what comes. But I think from what we saw in different sectors like banking and so on, we can already predict quite a lot of things happening. Like the role in advanced monitoring and maintenance. The ATSEP is going to manage system health in a predictive maintenance approach with AI-driven tools. Cybersecurity focus. Secure AI and traditional systems are used against cyber threats. Interoperability management. Ensure seamless operation across legacy and modern systems. We always have both, There's a transition for a certain time. Ground to air and ground to ground communication. Automation supervision. We oversee the AI-driven automated task. There will be automated tasks, and we have to oversee them in surveillance, navigation, communication. Data handling and system optimization. The ATSEP manages high-quality data for AI processing and system efficiency improvements. Regulatory compliance and safety. The ATSEP has to ensure compliance with international standards for AI-based systems and overlay safety. Let's drill a little bit deeper, because the question is, what does the IT guy or the provider have to do, and what does the ATSEP do? I try to drill deep and just try to separate the tasks. There's scope for errors from my side. Please correct me wherever I'm proven wrong. Data management. The ATSEP probably ensures CNS data is available for model fine-tuning and optimization. What data is given, the ATSEP can judge that. The provider and the data scientists, they provide pre-trained AI models using large data sets tailored for ATM. So normally it's the providers who do that. In some ANSPs, there's also in-house development for certain applications. System monitoring and control. The ATSEP monitors and fine-tunes AI model parameters for optimal performance. The provider and the data scientist ensure AI models are scalable and integrated into ATM systems. So that's probably coming from the provider, whereas the ANSC is providing the cloud where the applications are hosted. But as I said, it depends from ANSP to ANSP. Human-in-the-loop feedback and intervention, human oversight. ATSEP provides feedback to adjust model parameters, detect anomalies, and manually intervene during emergency situations. Of course, the ATSEP is the person to best understand when something is offset. So he or she is the person to best adjust model parameters when they are diverging from the optimal situation. They are the ones who can really detect anomalies. And the provider updates models based on the ATSEP feedback and system performance. You see, there's a very, very intense cooperation required here, which might also be AI-driven. But it shows you already that the ATSEP have to understand the thing about data. They have to understand what data is used for, what data is good, how data is perhaps anomal, and goes into the right direction. When the ATSEP has to intervene, this only works when the ATSEP has understood what is actually happening. System maintenance and updates. The ATSEP supports infrastructure for ongoing updates and fine-tuning of the models. The provider and the scientists continually improve models and pushes updates. The regulation and compliance. The ATSEP ensures AI models comply with safety standards during optimization. So there's a process when they change, and the ATSEP, of course, needs to make sure that they remain compliant during their evolution. The provider designs models to meet regulatory requirements and supports fine-tuning. So there is not a hermetic border between the two roles. They are cooperating, and this is a learning process. But when somebody tells me, well, the ATSEP is not really concerned, it's the ATM system provider, this is definitely not correct. The ATSEP needs to understand what the data is about. The ATSEP needs to understand what the applications are doing. The ATSEP needs to understand how the applications are monitored and controlled by the AI applications by the AI services and to oversee it. If the ATSEP doesn't understand that, he or she will not be able to provide the human oversight which is required by 2017 373. Ethics is important. We need to eliminate biases present in AI training data. Transparency, as we talked about it a couple of times, we need to ensure that AI decision-making processes are transparent and understandable, XAI, explainable AI, and accountability, determining who is responsible for AI system failures. Be aware, 2017 373 gives us ATSEP responsibility. We cannot delegate responsibility away. We cannot say, hey, it was AI, it wasn't us. No. Accountability needs to remain relevant. Well, the profile of the ATSEP is changing, and there are key social skills needed in an AI-driven environment. The world of the ATSEP has been static. I mean, it has not been static, but it hasn't been dynamically changing all the time. Yeah, but the today's or the future ATSEP's career will be characterized by continuous change with increasing pace of change. Important skills that we need is emotional stability and mental balance. The ability to change and to evolve during the career is important because things will change all the time. I put, the ATSEP in a tent because he or she need to disassemble the tent regularly and rebuild it on a different place. So it's not a static home anymore. We're nomads now. Our nomad's land is the world of AI-driven ATSEP. What will define the pace of gradual transformation? I love that image of that horse, looking at the old timer and wondering whether this crappy thing will replace it eventually. I mean, of course, old timers were old timers in the first days, but they evolved rapidly to some really nice cars. And I'm sure that AI will do the same thing, So what will define the pace? Migration of NSPs to cloud-based architectures. If the NSPs don't go to the cloud, might be private cloud, which they control and not the ATM system providers, manufacturers, then they will lose control. They will not be able to evolve it to an overall maximum. The availability of AI-based applications, but they're coming rapidly. Availability of sufficient real and synthesized data to train the models. Trust. Regulatory readiness, we talked about that, depending on the stakeholders, trade unions, and lobbyists. What I'm considering here is large-scale transformation. I'm not considering the widely practiced use of AI to write code, automated services, and AI-supported text, which we find everywhere. Even here, I used it to optimize my English. Don't forget, it's iterative. It's not coming, but it's coming. It's not coming in one step, but it's coming rapidly. I talk a bit about cost benefits. Of course, with AI, we've got enormous productivity gains, financial gains, but TBO, trajectory-based operations lead to shorter trips, less fuel consumption, higher customer satisfaction, probably can transport more passengers with less effort, bigger, better, scalable, meaning higher throughput. Less human resources when ATCO and ATSEP are gradually replaced by machines. Replaced? The moment we don't find enough people, so it will not be a problem. But will there be a moment where we need less ATCO, less ATSEP? It's the future to decide. I would say probably yes. You might want to read Max Tegmark, Life 3.0, to get more insight about this. Or I think that's a good book to read. Centralized data centers, less hardware, better to protect. And the ecological sustainability gains per passenger, we have less fuel consumptions. Of course, there is that conflict, more energy consumption in the data centers. They would need to be compensated by green data centers, solar-driven data centers. I think eventually we will save fuel, we save energy costs. And competition like DeepSeek from China showed that we can work with much lower levels of energy consumptions if we manage the resources in a more intelligent way. Safety gains, AI-controlled TBO, air-ground, ground-air, ground-ground interaction will be safer, predictive maintenance, and AI-controlled system monitoring and control. If the ATM providers open their system, if we get them away from the proprietary solutions. Gartner talked about business value. I mean, these are figures that you might know. 15.8% revenue increase according to a survey. 15.2% cost savings. That's general. That's not just the aviation world. 22.6% productivity improvement. Lots of gains are on the horizon. I think it would be stupid if we don't harvest them. There's AI test projects in progress. I love the Bluebird project by NAX and the famous Alan Turing Institute. What they do is they build a digital twin, and in this digital twin they reproduce a real life architecture, and what they do is, in the reproduction, they create the world's first AI system to manage a section of live airspace alongside air traffic controls. So in the digital twin, things can go wrong and it doesn't matter. So let's rather train it there. Research themes are built in a real-time digital twin of the UK airspace, develop AI agents for safe and efficient air traffic control, ensure AI tools are explainable and trustworthy. So you can read more, and of course, more examples are found in Eurocontrol Fly Forum. How is AI shaping aviation? AI have to understand it. How deep? There will not be the developers probably of AI applications, but they need to understand the data. They need to understand the impact. What our company Skyraider, have developed for AI is a solution where, in a non-code way, the ATSEP can walk through with real radar data, walk through the whole concept of data collection and labeling, pre-processing, model development, model optimization, and then deploy it in a DSP and see with a real little miniaturized radar. Many of you know our next gen radar. You can test it, whether it understands your finger signs, whether it understands the difference between a chair and a cupboard, for instance, whether it understands it's able to differentiate various aircraft models with which you trained it. So AI model awareness, the ATSEP needs to understand AI modeling and optimization processes to be able to support, suggest changes, and intervene. In our technical qualification concept, we implement small representative models. We cover, as I said, data collection, labeling, data pre-processing, model selection development, model optimization, testing, and deployment. And of course, the ATSEP needs to understand the ethical and organizational challenges. Fairness, transparency, and accountability are important. As I said, the ATSEP, the training academies for ATSEP, we cannot delegate responsibility. The ATSEP needs to understand it. And It's not rocket science. Of course, yeah, perhaps it is rocket science, but it's understandable. And here, just a little bit, a little deeper insight. What we do in our AI training. It's all hands on. There is no code required. You measure with a little in-house radar, less than 5 milliwatt beaming power, by the way, less than a mobile phone, so it's not dangerous. And then you train your model and you deploy it to the DSP, and then you measure with the radar whether it understands your finger signs. So here, this is an example where we did that. You get from us the AI training system, operated through Radar Control Center, and of course the radar, all the training guides, and the teacher training. The system communicates with our AI server. We provide one, so there's no connection to the cloud in your training world, but it's all cloud architecture that you have. The whole training concept is pretty much similar to what you saw in our presentation before, just in a more simplified way. Methods provided are project creation, dataset generation, labeling, neural network validation, evaluation. So there's videos and there's more details available if you want the slides. There's even expanded versions where you can, for instance, detect jamming or errors. And this all is part of SkyRadar's architecture, where we can mix radar sources, FMCW sources, sonars, with AI, with simulation. It all goes to our cloud server. And many users can learn concurrently. Of course, you can connect hardware systems, software systems, and so on. Last point, don't panic. It's perhaps much, but it's not complicated. You all will be able to do it. And we, SkyRadar, at skyradar.com, are at your side. We help you, we provide the solutions, and we are ready if you need more information. Thank you very much for your time. And if you are interested in more, just come to www.skyradar.com. Just contact us and set up a meeting for your civil or military aviation academy. And we'll make sure that transition to AI will be fun and very efficient. Thank you very much for your time. See you soon. Bye-bye.